So let me start with one question. You must have seen many photographs and many images of airships. I'm also starting with a PPT like that. Can you tell me quickly, anybody in the audience, what is special about these pictures? Can you guess? Let me tell you, these are all photographs of airships made in IIT Bombay by students like you. That is unique about them. These are not from internet. These are not somebody else's photographs. These are airships made by students like you and researchers of our lab. So therefore, these are all our own airships. Okay. Now, as you know, there are three types of conventional LTA systems. LTA, you know, stands for lighter than air. I'm going to use it very extensively. Correct? So, hot air balloon, aerostat, and airship. So you can see, for example, that hot air balloon basically just works on hot air to get buoyancy. It has no directional control. It just goes where the wind takes it. The aerostat has a cable which is attached from the envelope to the ground control station. It is unpowered. It only has stabilizing surfaces. But on the extreme left is the airship, which is powered as well as it has directional control. So today we are going to remove aerostats and hot air balloons from our radar, and we will focus only on airships today and tomorrow. So typically, just like any aircraft, there are four forces acting on the airship: lift, thrust, weight, and drag. Now, two of these forces are natural and two of these forces are made by us. So which are the two forces which are natural? Can someone tell me?
So weight and drag.
Weight and drag, right, are natural forces. Lift and thrust are to be created by us. In the case of airships, we don't even have to worry about lift because it gets created due to the buoyancy of the gas filled inside the envelope. So even lift becomes a natural force, and this natural force is a function of the enclosed volume of the envelope and also on the buoyancy of the gas inside. So on the bottom, you will see the only formula that you will see in my presentation today. Remaining is only going to be pictures and videos and photos, etc. So the buoyant lift LB is equal to the volume of the envelope V into the difference in the density between the ambient air outside and the gas inside. So if you want to increase the lift because you want to carry more, so how will you calculate the payload capacity of an airship if you know the value of LB? How will you calculate how much load the airship can carry?
Force is equal to rho GV.
So are you saying that you can carry lift, you can carry a payload of rho into G into V, rho G into V? Is that what you are saying, that you can carry a payload equal to rho G into V? No, that is not true. If you know that the lifting capacity of buoyant lift LB is equal to V into density difference, how will you calculate how much payload you can carry? What is meant by payload, do you know? Someone please tell me what is meant by payload in any aircraft.
So the extra carrier weight other than which we can lift with our aircraft.
Other than the self weight, correct?
Yes, sir.
So from the buoyant lift LB, if you subtract the self weight, what will you get?
Lifting capacity.
Lifting capacity. And you can use the entire lifting capacity for payload, but then you'll have no margin at all. You might say 80% of the lifting capacity I will use for carrying payload and 20% I will keep for something else. Or you might say 90%. It's up to you. Correct? Okay. So just like an aircraft airships also has some components. Okay. Now let me give you some idea about this airship. Of course, I'll talk about it in the evening, so I'll not talk about it now. So like an aircraft has got wings which generate the major lift. An airship has an envelope which is full of the LTA gas that generates the lift. Then there is a gondola on the bottom in which normally you put all your payload and all the other things that you are carrying in the airship, including in this case the power plant. And on the back you have these 4 control surfaces. So now let us look at the similarities and the differences between airships and aircraft, fixed wing aircraft. So can you please tell me what are the differences based on this photograph? Difference between an aircraft and an airship looking at the photograph.
Compared to aircraft, airship has extra control surface.
Very good observation. I am very happy, Shubham. I'm extremely happy that you observed that in an airship, we have 4 control surfaces, 2 vertical and 2 horizontal. In the aircraft, you have only 1 vertical and 2 horizontal. Okay. Can you tell me the reason, Shubham? Why do we need 4 surfaces for an airship? Whereas 3 are okay for the aircraft? Yes, no problem.
Sorry, sir, I don't know.
Yeah, if you don't know, you guess. You say I don't know, but I would like to guess. Okay. Anybody else would like to try?
Maybe those are less effective than aircraft.
Very good. Why are they less effective? You are right. Why are they less effective?
Sir, because the speed will be slow, so therefore
Exactly.
we'll need.
Very good. Very good, Arup. Arup, thank you so much. So you are right, Arup, because the speed at which airships fly is not as compared to the aircraft. Therefore, you need larger area for the control and stabilizing surfaces. Okay, both stabilizing also and controlling also. And if you make only one surface on the top, it is going to become very large and flexible. And even the envelope is also generally flexible. Of course, there are many types of airships, which we'll see in the next few slides. So yes, that is the reason why airships need larger number of control surfaces and stabilizing surfaces. So we have 4. Very good. Okay. Any other observation compared to aircraft?
Sir, it has a huge envelope, unlike aircrafts.
Exactly. So in the aircraft, the gondola which carries the passengers, payloads, etc., that is actually the fuselage, and that is larger than the wing in size generally. Correct? But in the case of airships, the gondola is so small compared to the large envelope. Excellent. And of course, a young lady mentioned in the beginning that there are no wings. Yes, that is also true, because airships don't need wings because they generate lift by buoyancy. Now, my question to you is, do airships generate lift only by buoyancy, or is there some other mechanism also? So tell me one thing. Right now, you are seeing the airship flying. Can you see some ropes hanging below it? They are not very clear, but are you able to see in the image? There are some small ropes which are hanging below the airship. Can you see them?
Yes, sir.
So are they vertical or are they having some inclination?
Inclination.
What does it mean? Is the airship stationary or flying forward or backward?
Flying forward.
Correct. So when this airship flies forward, and you can also see there is an angle also, isn't it? You can guess the direction of the wind by the parallel lines of these handling lines, and you can make out that the airship is at some angle. So that means there is some angle of attack between the envelope and the ambient wind. So what will happen if a body like this flies at an angle of attack in the wind? Think first. Will there be any lift acting on it? Or let us say, see, lift and drag are only components of forces. Will there be any normal reaction? Will there be any reaction acting on this body as it flies in the air? Or will there be no forces and movements on the body when it is flying in the air? So a cylindrical bluff body is moving in the air at some angle of attack. Will there be any forces acting on it?
Lift force.
No, not only lift force. So there will be a normal reaction acting on it, and that when we take into components along and normal to the ambient relative wind, we call it a lift and drag forces. So some additional lift will be acting on this airship as it moves forward. That lift is called as dynamic lift, and the lift which is coming because of buoyancy, even when it is stationary, that is called as static lift. Okay, so airships have two kinds of lift: buoyant lift, which is maybe 80%, 90%, and dynamic lift, which will be 15 to 20% generally. Okay, right. So we look at types of airships. There are four basic types of airships. There is a rigid airship where the entire framework outside and inside is rigid, and then you have some gas bags in which you keep the LTA gas. This is a very old technology and this is not generally used today. Although there are some people who are trying to revive this technology back, but generally today you don't see rigid airships flying. The other extreme is a non-rigid airship in which there is no structural member inside. The shape is maintained purely by internal overpressure. Yes, there are some ropes, etc. inside which are there to transfer the load, but there is no solid structural element inside. Then we have an in between these two called as semi-rigid. So does anybody know about semi-rigid airships? You are doing a course on LTS systems. Can you tell me the difference between rigid, non-rigid and semi-rigid?
Rigid are fixed to ground. Semi-rigid are tied with the rope to the ground. And
No, I'm sorry. Rigid is not fixed to ground. Rigid. What will it do if it is fixed to ground? Then it is useless. It has to fly. So right now it is attached to the ground because people are supposed to land, or maybe there is some maintenance work going on. But it's not, this slide is about the structural configuration.
Sir, the envelope will be supported by some internal structures in rigid airship.
Okay, so envelope is supported by some internal rigid structure in rigid airships.
Yes.
That's what you're saying, na? Okay. So what about what you see, the outer structure? Is that rigid or non-rigid? In a rigid airship, let me just remove the other photographs. In the rigid airship, there is an internal structure. I agree with you completely. But what about the outer structure?
It's rigid too.
It's rigid too. And do you see a gondola here?
No, sir.
No.
So, but there is something in the front of the bottom. What is that? I mean, if I take my mouse somewhere here, can you see my mouse?
Yes, sir.
What is that?
Sir, maybe it's a gondola for the controlling of the.
Correct. Very right. That is basically a cockpit. And this has to be outside the airship because pilots have to see. Okay. So where are the passengers sitting in this airship? They are sitting inside the airship. The passengers are sitting inside the airship. Okay. So the passenger cabin, like a fuselage, is inside the structure. And the outside structure is rigid. So everything is rigid here. And there are gas bags inside. In this case, nothing is rigid inside. So there are no passengers inside. The passengers are sitting in the gondola below and the pilot is in the front. So what is happening in semi-rigid then?
tied with rope to the ground.
No, my friend, all airships are supposed to fly and all airships are tied with the rope to the ground. So don't go by tying with the rope on the ground. Tell me about the structural configuration. This question is about structure. How is the structure of semi-rigid airship?
The sitting arrangement both in gondola or in airship?
So do you think that the sitting arrangement is inside the airship? No, not in this case. So here, nobody is sitting inside the airship. They are all sitting in the gondola. In fact, you can see them. I can see one red t-shirt. So like the non-rigid airship, they are sitting in the gondola below the airship. There is nobody inside the airship. So then what is inside the airship?
Some internal structure for support.
So if there is an internal structure for support, then it is rigid airship. Then why do you call it semi-rigid?
Internal gas.
Internal gas is
Internal
also there.
expansion.
Sorry, gas is also there in the rigid airship. I told you there are gas bags. No? You need to have buoyant gas bags inside. So if the semi-rigid airship has an internal structure and the people are sitting outside in the bottom, then what is the difference between semi-rigid and non-rigid? This is
There may be not internal structure, only the gas is there.
so if there is no gas, if there is no structure inside, then it is non-rigid. Then why semi-rigid?
Sir, it has both rigid and non-rigid characteristics. Like it will have structures to support the envelope as well as the gas pressure inside.
And what about the outer covering? In the rigid airship, we had a rigid covering. So in semi-rigid, what is the covering?
Sir, it will be the covering will be somewhat like non-rigid structure, sir.
That's right. So it is called semi-rigid because neither it is fully rigid, neither it is non-rigid. It is in between. So what is in between? Do you see the blue line on the bottom? Okay, on the bottom half of the airship, there is some blue colored line. And can you tell me in the non-rigid airship, where is the engine?
Sir, within the behind of the cockpit, sir.
No, not cockpit, gondola. See, there are three things there.
Yes,
Cockpit
sir.
is in the
Gondola.
front. There is a passenger cabin or a gondola. Yeah. So in the case of non-rigid airship, the engine is mounted on the gondola. In this case, on the gondola rear side. Okay. Where is the engine in the case of rigid airships? You cannot see it, but you see there are these four things you can see. It's actually mounted outside the airship. Okay. It's not very clear because the photograph is very old. So 1, 2, 3, 4, and on that side. Okay, where is the engine mounted in the semi-rigid airship?
Sir, maybe backside.
Yeah, you can see on the back side there is one engine, very right. So you can mount an engine on the back side of a semi-rigid airship because there is some structure available there. Okay. Anywhere else you see an engine? Do you see another engine in this airship, semi-rigid airship? There is one engine here also on the side, which was not very clear to you probably. So that's why you could not guess it. And this engine is tilted upwards. So that is the beauty of semi-rigid. Because there is a structure inside, you can mount the engine on the envelope and not on the gondola. And finally, we have a hot air airship. This is a hot air balloon, but the shape is like an airship. Okay. So these are the four kinds of airships. And we are going to work on non-rigid airship. Right. So you have all heard about Hindenburg?
Yes, sir.
Yes,
What do you? We are back. So tell me about Hindenburg. What do you know about Hindenburg? I think I'm going to skip this. I'm going to skip this because let me just come back to the revival of airships. Okay. So let me show you some modern airships. Okay. This is a modern manned airship. There was somebody who began talking about Hindenburg. Can you please tell me?
Sir, it was an accident which was famous in the case of airships.
Is that all you know about Hindenburg?
Yes, I just know. I read an article that it caught fire and there was a disaster during the docking of the airship. That's all I know, sir.
Okay, fine. So what you know about Hindenburg is that it caught fire and there was a disaster. Okay, let me tell you something about Hindenburg that you don't know. Hindenburg was the largest airship ever built and launched in 1936. Okay, it had 16 bags of hydrogen. It could travel 10,000 miles continuously 5 to 6 days at a cruise speed of around 80 kilometers per hour. It could cross the Atlantic Ocean in about 50 to 60 hours. And before the accident, it had completed successfully 10 round trips from Germany to USA. All this was in 1936. And before that, when the fixed wing aircraft were struggling to actually perform. There was nothing available at that time which could fly such a large distance. The disaster took place in 1937. What you know is that 35 people died. What you don't know is that 62 people survived. That means nearly the double of the people who died, the other people survived. Now please tell me how many accidents about fixed wing aircraft you know in which the aircraft catches fire while coming into land and 62 people survive. Okay, this is the information regarding Hindenburg which is not popularized. What is popularized about Hindenburg is this, that it caught fire, there was an accident, airships are unsafe. And that is why there was a hibernation of airships from 1936 onwards. After 37, there were 2 more accidents. One was in the UK with an airship called as RH-101. Incidentally, it was coming to India from London and it caught fire somewhere near Paris. And then the next accident took place in USA. After that, everybody thought airships are dangerous, airships are unsafe. But they were revived in 1985 by this airship called as Skyship 600B. Now I'll show you a short video of today, how the airships are. So what I want you to do is, I want you to notice, first of all, the location of this airship operation. I want you to count the number of people on the ground, and I want you to look at the airship, how it is operated. Can you see the video? Please confirm.
Yes, sir, we can see.
Look at the engine being tilted upwards. Location is a ground near the highway. This is not an airport. This is a simple ground near a highway. There is no requirement for a runway, takeoff length, landing distance. It is a pure vertical takeoff and landing aircraft. Three engines, one on the back and 2 on the sides. This is the modern airship that is flying today. Okay, whenever we talk about any particular system, we talk about what is called as a USP. What is the meaning of USP? Anybody can tell me what is meant by USP? What is the meaning of the word USP? If you don't know, do a Google search and tell me.
Sir, unique selling proposition.
Very right. USP stands for unique selling proposition. What is unique about airships? as compared to other aircraft. So the list is there in front of you. Do you have any questions or any clarification on these points?
So no clarification required. Sir.
Okay, let's go ahead and let me show you some of these applications now. These are the existing application of airships in the order of importance. All over the world, airships are mostly used for advertisement and product promotion. The next application is aerial observation and surveillance, and then other applications. So here is an example of airships for advertisement and product promotion. Okay. This is an example of aerial observation. This particular airship was flying in Las Vegas. It had, I think, 4 or 6 seats. And you could be on the airship as a tourist to look at Las Vegas by air. Tourism. This is the gondola of the airship which I showed you. It has 12 seats, I think. So let me show you a small video clip. So this is the beauty of flying in an airship. You can use it for covering sports events without disturbing the animals below. You can use it for what is called as corporate hospitality, in which the entire team of around 10, 12 people can be made to travel up in the air and just go around. But there are also some very interesting applications. One of them is the usage of airships for anti-mining operations. Okay, so you can fit a sensor like in this. On the right hand side, you see there is one special camera fitted on the front of the airship. Can you see that? This big round white thing.
Yes,
So
sir.
this is the special sensor which is sensing any metallic objects buried inside the ground. And from that, you can identify the landmines. So I'll show you a small video of how it is done.
As patrons,
It's extraordinary technology. Right now, there's something of 70 million landmines out there. People are being hurt daily. We're not really sure exactly where they are. And instead of what has now become an antiquated technique of searching them out with metal detectors or dogs, this is an extraordinary technology that is able to monitor hundreds of square meters a second and to find exactly where and what kind of landmines are there, and which will lead to a much quicker removal. So it's an extraordinary technology. Right now it's just sitting on a shelf and it needs to be put into action, and that's why we're here.
we as a group have decided we're going to get the funding. We have people standing by that will fund Mineseekers and our equipment and our technology and getting the first vehicle actually in the air, floating in the air. Our goal is, I believe, to make 6 or 7 of these and have them in various parts of the world. And if for any reason everything else fails, every hairdresser, every friend, probably half the flight people on Virgin Airlines, and everybody we know will make a contribution. But we are dedicated to getting this done, and we are very certain we have the financial means to be able to do that without relying on politics to get it done. But we need political help, obviously, once we're in the country with groups that will help remove them.
Okay. So could you understand? You can scan on the ground and then you can identify mines. Any questions?
No, sir.
Sir,
Yeah. Yes, please.
what distance it scan means ground to airship?
So it flies very low. As you can see, there is a sensor, and that sensor has to be so. That is the beauty. You can even fly a few feet above the ground and still not have any problem. So it flies very low, because the lower you fly, the better is the accuracy of determination.
Okay, sir.
Anything else? So I'll go ahead. Another application of airships is the surveillance, or used by security agencies. In many Olympic Games, airships have been used for aerial security. So I'll show you one example of the Olympics in 2012 in Tokyo, I think. I'll just show you a time-lapse video. So what I want you to do is, I'll go a little bit fast to save time. So do you see one airship flying in the air? Yes or no?
Sir,
Yes, sir.
So what is it doing? It's continuously flying in circles. Okay? Because somewhere here is the stadium. There is a stadium here. So it is just flying in circles, keeping an eye on the stadium. Okay, this is a high-speed video. Okay, so now it is evening time. This is the stadium in the center. Can you see the stadium? There are some lights there.
Yes, sir.
So where is the airship? The airship is here. It's flying. Correct. Now it becomes a bit dark. The airship is still flying. Some ceremonies are going on. The airship is still flying. You can see one white colored patch in the sky. Right?
Yes, sir.
Yes, sir.
Now, yeah, so something is going on, something is going on, something is going on. Now some events have started. There is some kind of inaugural ceremony. So a lot of lights are there. Okay, where is the airship? The airship is still in the sky, but you can't see it. Suddenly you will see one flash. When you see a flash, you will see the airship in the sky. So it seems that there is nothing in the sky, but actually there is an airship in the sky monitoring the things.
Sir, what is the maximum endurance time for airship?
Very good question. So if you want to fly like this continuously over a stadium, right from the afternoon to the evening, okay, 1 minute, there is some festivities. Let us just see. Yeah, you can see some festivities took place. But if you see in the flash, you will see there is an airship in the sky. So yeah, you can see now the airship.
Yes,
Yes.
sir.
So she's
Yes.
there. She's there. So you can fly an airship non-stop like this for about 8 to 9 hours. Okay. But the world record for an airship is 52 hours non-stop flight. That is why airships, the best thing they can do is fly very quietly, without much pollution, without much noise, without much vibration for a long duration of time. Okay, right. So now I'm open to any queries. All your questions regarding airships, I would like you to ask. I have about 7 minutes time, then we will take a short break.
Okay, sir.
sir, Sir, can you please explain the propulsion techniques in rigid airships? Because it was not clear, sir, that one.
See, in the rigid airship, there are some engines which are attached to the structure hanging outside. So there are 4 engines here, and there are 4 engines there, and in this case, they were all piston prop engines. See, you have a structure right from the front to the back. You have an inside structure. You have an outside structure. So you can actually mount the engine roughly anywhere. There is no problem in rigid airships to mount the engine.
Yes, sir.
Other questions?
Sir,
Sir,
what is the maximum speed of latest airships?
About 100 kilometers per hour. Approximately 100 kilometers per hour is the maximum speed of modern day airships. Passenger
Okay, sir.
carrying airships. Yeah.
Okay, sir.
Sir, how much cost for the one airship?
How much cost for one airship?
Yes,
So so this Zeppelin NT airship, I had taken some estimate in the year 2003. It was coming to around $6 million US. Okay, in 2003. Today, I don't know. I'll have to just check online, or I'll have to ask the company. But they are very expensive because they are very special. They are unique. Very few are available. But they are very costly.
sir, in rigid airship, the engine used for lifting purpose or controlling?
No, the engine is used for giving forward thrust. The tails are, you can see there are huge vertical tail and horizontal tail. And there is also a rudder and navigator. They are used for control and stability. Engine is used only for forward motion. The engine is not swivelable in many rigid airships. But in the case of non-rigid airship that you are seeing here, the engine is swivelable. And also, Zeppelin NT also, the engine is swivelable.
Okay, sir.
sir, which type of sensors are used in airships?
Sensors. So there are a large number type of sensors. Sensing for what purpose? When you say sensors, what do you mean? For what purpose? Do you mean instruments in the cockpit?
Yes, sir.
They are same like a small low-speed aircraft. Any aircraft that flies at 70, 80 kilometers per hour maximum speed, that kind of instrumentation is there in the cockpit. So you have the same things. Okay, let me show you a small video then.
From her hangar at the Royal
Yes,
Aircraft
we can see.
Paddington, the traditional shrine of British airship aviation.
This is
Now, this
1985.
famous landmark has the
Quite
latest
old.
generation of lighter-than-air craft, designed and built by Airship Industries and packed with state-of-the-art aviation technology.
He is the pilot.
The world's media were out in force to witness the 600's maiden flight, reflecting the global interest in this multi-purpose craft. The 600 is a stretched version of the earlier Skyship 500, with passenger capacity doubled from 10 to 20 seats, cruising speed increased to 55 knots, airborne endurance to a remarkable
55 knots
48
means
hours, and virtually
about
every
100
other aspect
more
of
than
the
100
craft
kilometers per hour.
refined and upgraded.
Thanks, clear the vectors.
Little bit old.
Clear number 1.
Because of 1985.
Clear number 2.
Satisfied with the running of the twin turbocharged Porsche engines, Chief Test Pilot Commander Nick Bennett was now ready for takeoff.
You can see the engine is swiveling. The engine is swiveling. For easy takeoff.
Using only a low power setting,
And now
the
the engine is
600
swiveled
executed a
forward.
perfect zero-roll takeoff and climbed steeply and quietly into the sky. She had